My name is Falcon Liu from PlayNitride. I'm marketing director. I'm in charge of new business development and also all things about marketing and technologies.
So at PlayNitride, you are on your website. It says you want to change the world. You want to bring new display technology, the MicroLED. You have are you talking about 89-inch 5K ultra-wide MicroLED? Is this real?
Yes, actually, how we want to change the world is want to use MicroLED to share lots of different ideas in our life. Not only like your laptop, your TV, and we will show later there are different options or different solutions for MicroLED technology. And here, this one, the first one, what we showed, actually we showed last month in Taiwan, Touch Taiwan, there's an exhibition, and this is an 89-inch 5K, 32 by 9 curved MicroLED display. And I'm sorry that because this is by video, so maybe you cannot feel that it's very big and curved and good picture quality. But
maybe we can link to the clips here. Maybe post the videos later, so people can see the 4K quality. You have 4K of this video, right?
Yes, yes.
So that's a big leap from when we did the video in 2019. You had this size right here.
Yes.
This was transparent, right?
Right.
And you call it PixeLED?
Yes, that's technology we call it PixeLED display.
So what's the status on the PixeLED, or is that basically the 5K 89-inch?
Oh, actually, there's that's different technologies. So now what we show here, this is 5K display that we call PixeLED matrix. So the technology is MicroLED on PCB. So this is a PCB-based technology. And previously showed the transparent technology that's MicroLED on TFT. So we will have different video to show the MicroLED on TFT's progress.
And you also have a small one there?
Yes. And that one, actually, we don't have anything about this smaller one this year. And this this is passive matrix, even no TFT. But this year we have MicroLED on PCB, Micro on TFT, and also MicroLED on silicon.
When you say PCB, that sounds like like it doesn't seem to be something that's like, it's not transparent, right?
No, this one is non-transparent. The key is the PCB is printed circuit board, just like the traditional your driving board or anything in your electronic devices. But with this PCB, the beauty things is that it's like 5-inch size, so we can use these small pieces and tile it to a very big screen, just like we saw something like a traditional LED screen. A very big screen, so it's tiling by module, a lot of modules. And this technology, we're doing the same thing, but it's using MicroLED with much smaller pieces and much higher pixel density.
So are you in Taiwan?
Yes.
And you actually manufacture it right now, or it's just prototype manufacturing line, or what's the status? Because if you have an 89-inch 5K, that means you're already doing a lot of these MicroLEDs.
Okay, for different technology, we have different progress. So for this 89-inch, actually, this is the first time we demonstrated to the public. So there's a very limited output right now for some of the potential customer, their evaluation. So it will start the mass production later after they check evaluate the devices. And for MicroLED on TFT, something is undergoing, will go for mass production soon.
So that 5K display, 89-inch, did it have 0 dead pixels?
Well,
it's
I can say
perfect.
almost.
Almost, okay.
Yeah.
So,
Because the technology is different, so we can easily do running the inspection and repair the or change the dead pixels. So for this one, because it's PCB based, so easily if we found anything wrong, then we can just plug and play, just remove the module with defect and change to a better one.
what's the pixel density? You say 59 pixel per inch?
Yes, this is the same as 75-inch 4K.
All right. This is like a specific pixel density that is defined as micro, right?
Yes.
Do you have also other videos you can share?
Sure. Okay, let me change the video to the second one.
All right. Right there.
Okay.
So what does this one show?
This is the, as I mentioned, MicroLED on TFT. So the first one, this is a 1.39-inch circular display, and that is 338 ppi, which is the highest ppi for MicroLED on TFT.
Your expertise, is it mass transfer of these LEDs? Is that a little bit what you're doing?
Okay, PlayNitride, we have the epitaxy, wafer epitaxy process, and we make the micro-LED chip by ourselves, and then mass transfer from wafer to the backplane, like this case, transfer to the TFT backplane. So we are expertise, including all the key parts to make the micro-LED display.
All right. So there's a big. It's like I don't know if I want to call it like a gold rush, but it's the big next thing in the display industry, right? Everybody wants to try to figure out how to make the micro LED in the best way, and yes. Some people are making them on like wafers for like small displays, micro displays, right? And others are trying to make them big. Like Samsung is showing the wall. How is it different what you're doing compared to the Samsung wall, for example?
Okay, their technology, I think they are very good for tiling technology because they have lots of experiences. So they know how to make the display become a consumer product. That's their strong point. But for the micro-LED chip or micro-LED transfer, the mass transfer itself, PlayNitride has better technology and understandings.
What's the background of the team at the PlayNitride? How do you have this expertise? How do you figure out how to do this? Are you coming? Is it a team coming out of university or?
Oh, okay. For the very first founders and also the beginning, that's most of people are coming from LED industry, so they start to form a company, and then because we want to do something about LED, so we found lots of topics, and micro-LED is one of them. At the beginning, this topic is not with high priority because we don't think it can happen so soon. But one of our key customers just joined us, just working with us and pushed us to the market. So that's why micro-LED, the progress is much faster than our expected. So we started from 2014, and only 7 years, there's already something can go for market. That's much faster than like OLED or the LCD technology.
So how soon can this be in a mass market?
Well, this year, but you can find in the consumer market. But I have to say, because this is new technology, so the price is super high. So they call it a luxury segment. not only premium segment. But we believe this is the first step. So once it can go for mass production, then later it can become lower cost very soon.
Because the advantage of the whole LCD monster, which is the industry of the LCD, is that the price is so low, right? So is the microLED going to come in and provide larger sizes, better colors, more contrast, more brightness, and hopefully match the price eventually?
Okay, I think most of the product specs will be much better than LCD. However, just like OLED currently is the price still higher than LCD. So I think the same thing will happen in microLED. MicroLED technology, it's new, so it was starting from emerging applications or something that new. LCD or OLED, they cannot make it. For example, like transparent or the tiling to ultra large or any aspect ratio screen. So that will be the beginning. And later, the cost going down, but I don't know if that will replace LCD in the long future. But for the next 5 years, the cost will drop, going down like 90% compared to now.
And if I just show one of the videos we did at Display Week 2018, where you got a prize at the iZone, I think, right?
Right.
There's been a lot of progress in those 3 years. This was just a small display.
That's correct. That's only 3-inch only, and it's passive matrix, only 128 by 128. Now we have 89-inch with 5K, only 3 years.
That's pretty cool. So I guess the R&D labs at PlayNitride are a really interesting place to visit, or I guess it's top secret, right?
That's right.
Yeah, but where your colleagues or yourself, are you doing like all this R&D? Is it like in clean rooms with are you wearing a bunny suit and wearing special gloves to handle all these things, or how does it work?
Yeah. Okay, just like the display industry, microLED also need to manufacture in the clean room. So we need to like wearing the bunny suit to the clean room to work on this display. So we already have a production line, and it can capable to provide our big customer to make their TV with a certain volume. So compared to like our understanding of mass production, maybe the volume is not that huge, but it's a start. So we already starting the productions and provide to our customer.
So I have like right now I'm using a 65-inch. It'd be awesome to get bigger. Is it one of the dreams of microLED is to provide much bigger screens for people, like 120-inch?
Okay, actually
150-inch.
No, that's the limit. We don't have limitation. So the key is tell me your wall size of your living room. We will fill all of your living room. And even I heard some of the very rich men just said, please fill my airplane. Their private jet, they want the microLED inside, and they can feel like you're flying in the sky without any walls.
So that means it's not heavy?
No, it's the module itself is very thin and light.
Light, so it's not going to be a problem on airplanes. But how about for all the people who are not so very rich? Can we expect like 2023, 2024, maybe 2025? Are we going to be able to fill our walls with these kind of displays? And affordable, like affordable?
I think it depends on how you define affordable. But because the bigger size, of course, the price will be higher. But you can count it like a ratio. So like 65-inch become like a 130. Then it's double of the size. Then price may be double or more. So maybe we can expect it something like that. the price will be linear to the size.
Because there's a magic company in Taiwan called TSMC, right? And the whole world depends on TSMC, and they make so many chips. It's like completely insane how many they can make, right? Are you able to plug into this kind of mass quantities? Because that's how you get the price down, right? If you can design your technology so it can be mass produced.
Yes. Okay, that's something like called mass production. Of course, that's our plan in the future, but it takes step by step, just like TSMC. That it just not happen in one night. They work for 20 to 30 years, become like this. So of course we will. I think the MicroLED, the speed of expansion will be very fast. So we will see that, as I mentioned, after 5 years later, the cost will drop to 95% lower, like 95% compared to now. So, which means that there will be lots of MicroLED chips producing and lots of MicroLED display in the market.
So I'm just going to show the 2019 video. Maybe you can skip. Do you have another video you can show? You told me you had 3 videos, right?
Right.
What does the third video you have show?
Okay.
All right, I'm going to share your screen.
Yes. So the third video that shows what I mentioned, MicroLED on silicon. So that's something maybe need to work with like TSMC or this kind of silicon company, because right hand side that's a $1 coin in Taiwan. So it's like 1.9 millimeter. So this is only 0.39 inch. And
so is this the wafer technology?
No, the driving backplane is wafer. It's on silicon, CMOS silicon. But on top, the display is using MicroLED, and this is 4 color. So this will be best good for like AR glasses or for the projectors applications like HUD.
How high resolution do you think these can be? Is there any chance you can make like a 4K display that fits in a smart glass?
Okay, I think that's not a problem, because the key is we need to get a CMOS backplane with that high pixel density or high resolution. So the demonstration we have here, because this is just a newly development. So our development purpose backplane. So later we will have a higher resolution and higher pixel density product later.
How do you do full color? Is it like just a no problem for you to do full color?
Yeah, you can see here, this is a full color one. And how we make it, this is kind of secret. I cannot tell the detail.
All right. So just to sum up, you have 3 different ways to make the MicroLED. Is that right?
That's correct.
Or 4? 3, right? So one is the transparent one.
MicroLED on PCB. That's for bigger size, ultra large size tiling. And second is MicroLED on TFT that can make like a circular one, or the transparent one, or anything for higher pixel density. And the third is MicroLED on silicon. That's for like this showing for projectors, for the HUD, for AR glasses.
Is there some chance that when you do the on silicon, that it can be used for very bright projector, and we can like project on the whole wall with using MicroLED as like a competitor to DLP or LCD projector?
Yes. So for example, like this one, because the 4 color brightness is about 20,000 nits, and we think we can make it higher to more than 100,000 nits by the our new solutions. So and for single color, even can be like several hundred nits. So this micro display is spatially make it very high brightness, because that for AR glasses or for projectors, HUD, that they require very high brightness from the source because lots of loss in the optical system.
So going from full color to single color, there's a 10x difference in brightness?
Oh, could be, because the
Could be.
Could be because a full color means that you need to put 3 different microLED chips, and that you need to tuning the white color point, so you will reduce the some of the performance. But if single color, then we can make 3 chips all in the same color, and we don't need to consider about the white point color, that it can boost to much higher brightness.
When you talk about TFT, and you talk about TFT being for transparent, but actually it can also be not transparent when it's TFT?
Sure.
And
sure.
how becomes like the performance of the TFT version?
Okay, MicroLED on TFT is native transparent, because MicroLED chip is very small. So if we want to make it non-transparent, which means that we had fill some of the black material on those transparent area, so that can be with very high, very good contrast ratio and very high good color performance. So maybe let me switch back to the second video. That also there's some of the videos that shows the non-transparent ones.
Because I put your video on.
Like this. I paused it. You can see the left hand side, that's microLED display, and right hand side, that's an LCD screen. So the color and brightness and contrast, the microLED is much better.
I guess one of the big challenges, but hopefully you figured it out, is the life on these, because people like to use their displays for a decade for some reason, How likely is it that these kind of displays, or is it possible to configure them in a way that dead pixels don't matter? So if they happen eventually, but then they will still look perfect. I mean, great, because there'll be like replacement pixels somehow in a pattern, or?
Well, that's something we need to consider. It's kind of new technologies. Even the LCD or OLED, they cannot repair by itself. So the way what we will do is we will do running the reliability test to make sure that for like more 10 years or longer, that it can ensure all the pixel is still alive and working well. So that's the same way for LCD or OLED, what they do. So the key is we need to make a good design, so make sure the reliability will be good enough to maintain for 10 or more years.
How about the OLED displays are said to have what do you call it, burn-in? This is not going to have this problem?
Sure.
No burn-in, right?
MicroLED technology. No, it's just like LED. It's inorganic. So turn it on, give the current, and it's on. Then turn it off, then it's off. So there's no any burn-in issue.
Nice. And how about going full brightness? Is there an issue about doing that, or is it sometimes? I wonder if some of these displays that advertise 2,000 nits and 1,000 nits or 4,000 even, I'm not sure, the ones that are very bright on the market, usually LCD with the quantum dots, or it could also be like when people talk about the OLED displays having a peak brightness around 700 or 800 nits. Is it only something that happens just a little bit in just a small part of the screen, and they cannot just run it all the time in this brightness? how would it be for the micro LED? Is it also going to be too hot if it's too bright for too long, or is it okay? Just go full brightness forever.
We can keep it full brightness forever, but the key is not the micro LED chip itself. This is we need to consider about all the driving or your power system. So if you make it to the full white forever, which means the power will be very high. For example, if you want to keep 2000 nits forever, then you will need to provide the power for 2000 nits. But if like for some of technology, for example, like OLED, they will drop the full white brightness because save the power to the whole system. The design will be easier. So it really depends on the product spec from customers or their application. So if they want to keep it all white, maybe like micro LED on PCB, that kind of solution will be better. But if there are some constraints for total power, then like a micro LED on TFT, they will be full white with full white with 1000 nits, but for peak brightness can be 3000 nits or 5000 nits. That's another option.
So let's say we have a micro LED going full power, 2000 nits on the whole display, compared to an LCD with quantum dot, 2000 nits, full brightness on the whole display. Which one is using less power eventually?
Well, under the full white, it's hard to say. Theoretically, micro LED will be better, but actually we need to also consider about the TFT design structure. So that's something we are evaluating with our TFT partners right now. So they will have different some of the new designs to reduce the TFT power.
One dream that I always have when I want to have a smartwatch, and I mean in the past I have that have reflective display, right? Is there any chance that the performance is going to be great in direct sunlight? Or is it just because you can do so much brightness that you are competing with the sun? Or is there any chance you can also reflect somehow? Not really, but like, I don't know, like not have the sun be a problem?
Well, the easy solution is we make it very bright. So then we can compete with the sunlight. And that's what we're doing right now. So with the very high brightness especially for the wearable devices. But your idea is good. Maybe some of the reflections can be added, and that's some of the maybe secret project we're working with our partner right now.
Nice. And actually, on your website, I'll just try to show right here. Sorry, I'll just bring it up in a second. You're showing that you want to target phones, laptops, TV, smartwatches, everything. Is that true?
Okay, that's our plan, but really depends on our customers. So actually, we talk to all kinds of display applications, but they have different applications have different thought for this technology, because some of them they want to do the replacement, some of them want to make something brand new design. So the application or solution will be quite different, and also some cases they need to consider about the cost or the price. So the timing for different applications will be different, but most of them are discussing with us and thinking about how to make the micro LED to their product or their applications.
All right, they're right here. This is your website, I think. Oh, there I have it. No, yeah, sorry, I can't figure out how to get it up right now. Oh, there it is. Yeah. So this is your website, PlayNitride.com. People can read more. And there you have this cool display where you're showing that the whole like NASA headquarters, yeah. And then there you have it, right? You're showing phone, tablet, laptop, and the car, TV, and 2024 they're all going to be micro-LED with your technology?
Yeah,
Maybe.
I think not. That's what we hope. But the technology introduction depends on the one is the evaluation, their evaluations tempo or speed, and also need to consider about their product strategy. So I cannot say the, when which application will be happen in which year, but I can say that all of them are talking with us, and some of them already get the demo kit, and some of them even starting to discuss about the detail of the spec.
What could happen? So there's right here. Let's take one comment right here. TFT glass is a good option for high current.
Okay, I think maybe not, but it really depends on the spec brightness. So if you just want like a 1000 nits or 2000 nits, TFT maybe still good enough. But if you want to keep it much brighter, or want to keep it a longer time, for example, like you want to keep 2000 nit for keep it running for a whole day, TFT maybe not a good option, but the TFT is still improving. So I cannot say that TFT is not a good one right now, but maybe some challenges, but maybe but I think they will get some solutions soon.
So on your website, you're talking about that you are virtually exhibiting at the Display Week, and we're doing this video as part of the Display Week 2021. That was virtual, right? But you also had a Touch Taiwan, which was real. It was a real event, like one of the first ones.
Yes.
How did that go? How was it at Touch Taiwan?
Okay, it's on I think end of April, and based on the statistic, I saw there's about 30,000 people to the exhibitions, and I believe most of them dropped by our booth.
All right, so there were big booths and people interacting in a physical trade show, and right there in Taiwan, right?
Right. So actually, in the real case, you cannot see the booth like this because crowded and full of people.
Nice. And there was some stuff before, some latest news. Opto Taiwan 2020, that was last year, but was that virtual or?
Oh, it's also the real exhibition.
So, but that was before the whole strange thing, right?
Yes, the last year, but only at that time we only demonstrate like a much smaller micro, not 89-inch 5K, but it's much smaller display, because at that time it's just we just come out some of the samples only.
And can you describe a little bit the company, how big it is, how many people you are, or is there a secret about some information about that?
Okay, we are PlayNitride. We're located in Taiwan, Hsinchu Science Park, and we have about 350 people working here, and around half of them is R&D, and the others are supporting, and also the technicians working in the fab. And we have it's starting from 2014. So right now we have a production line running also here, and actually we have several rounds of fundraising, and the valuation right now is more than $300 million.
Isn't there like some kind of like some talk of using MicroLED as a LCD backlight source?
Well, actually, in the beginning, yes, some people talk with us about using MicroLED as a backlight. But I think this will be the same question is why not using OLED as the backlight? So since the microLED can be the display, so you make the backlight means you will use something because right now it's new and expensive. So you need to use something new and expensive only for backlight, and the LCD performance only improve a little bit. Then why not just use microLED as the display directly? So finally, we don't make the microLED for backlight anymore.
So you're saying that using for backlight and using for display is nearly the same price?
No, of course, using for the backlight will be cheaper than the display because the microLED quantity will be less than to make the real display. But it's the same thing because it's using as the backlight, it's still LCD. So most of the performance is limited by LCD. So microLED backlight compared to maybe called right now mini LED backlight, the only benefit is we can make more zones or we can make the zones smaller. But the difference between the local dimming backlight right now and the microLED backlight, the difference is not that big, and but the cost will be much bigger. So maybe that's not a good idea to use the microLED as the backlight.
Do you use any quantum dots with your technology, or that's not part of the deal right now? Or you cannot say?
Quantum dot is, or we summarize this called color conversion technology. Color conversion technology also has some of the R&D project for that because some of the customers, they think they prefer to use quantum dot as their display. But as I keep mentioning, it really depends on the applications because for example, like automotive applications, they consider about the sunlight and reliability. Maybe quantum dot is not that good. Some of the car makers, they say they don't want to use quantum dot for car automotive screen. But some of the cases, maybe they don't have the indoor. Maybe they prefer to use quantum dot because they think quantum dot has some of the advantages.
Is it easy for you to change whatever pixel density, whatever size people want, and just like you can just like turn some buttons on the machine and it starts making different ones? Or is like a huge different, like you have to design a different molds and a nanotechnology size and stuff to do each different, so you prefer to stick to a specific pixel density?
Okay, just like LCD or OLED, if we want to change the pixel density or change the resolution, anything, then we need to have new toolings like photo mask, because different different resolution requires different photo masks. So including TFT and also the microLED chip, we also need something new. So it takes lots of money. And of course, we can do the customize, but just like LCD or OLED, if you want to customize your design, then you need to either you need to have a big quantity or you need to pay the tooling fees to make this.
Is it possible that in the future we will see how you make them, or is this going to stay secret for the next 10 years? I'm joking, but because there's a lot of...
I'm not sure. I'm not sure.
Yeah.
Maybe some of the parts maybe will be shown in the future, but maybe the most core technology will keep secret.
Because I guess you need to connect each LED and somehow, I don't know how it works. It's hard to figure out how that works.
And yeah, actually, maybe we can, there's some of we make some cartoons to show the ideas. But the detail, because it's microLED chips, which is less than 50 micron, or for our case, less than 30 micron. So if you even take a camera there, you just see the machines keep moving, but you cannot really see the details at all.
There don't exist any cameras that can film so small yet. You need the nano cameras, micro.
But for that camera, it will only focus for a very small area, so you just can see, oh, the chip is on, and then there's no chip and chip is on. So I think we will think about it to show some of the information in the future, but now it's difficult to both on how we can prepare the video. Another is most of the process is still in confidential right now.
Is it also confidential where the materials come from, or is it is it perfect to be in Taiwan? Because in Taiwan, there's all the different partners you can have for the LEDs, for the materials and everything. And right there, and it's right there, is your neighbors.
Yeah, so we got lots of materials or equipment from Taiwan, but it's not limited to in Taiwan, because also in Asia, lots of the Korea, Japan, or sometimes in China, they have lots of different equipments or the materials. Especially like Japan, they have very good material or some of the equipment that's with very high precisions. So we are not like limited to use any of the material or equipment. We just try to find the best one, and that can solve our challenges, and then we can make the production with better yield and better quality.
All right, because I don't know what the latest market analysis is in terms of who's dominating the world of LCDs. Or LCD, I guess, is China, I guess, and OLED is maybe Korea. I'm not sure, but and then what is Taiwan's market in LCD or OLED, or is it going to be the leader in MicroLED? It's hard for me to really know what's happening. I need to do some more videos.
Okay, in Taiwan, actually LCD still dominate on all because but the LCD development, their technology is good. So for very high new things like 8K or 120 Hz or something like sleep borders, Taiwan can make it, develop it and make it very soon. But for OLED, because that requires lots of investment, so currently, Taiwan, we're not so focused on OLED at all. And so that's the reason MicroLED will be very important in Taiwan. So we believe this will be the new generation of this display technology. So most of the Taiwan, both display makers and all the ecosystem, we all have some of the projects or some of the development for MicroLEDs. But of course, PlayNitride is only focusing on MicroLED display technology.
And it's possible that you might partner with companies in other countries that maybe will say, hey, we want to make these in Korea, or we want to make these in China, and you're open to all these business possibilities in the future, I guess.
We open to the whole world. So we have we talking to our potential customers in Europe, in Asia, both Japan, Korea, China, or Southeast Asia, and also if for the equipment vendor or the material supplier, we also use the from worldwide anywhere. So actually for us, there's no any limitation at all. So just maybe some time zone difference takes the communication longer, but there's no any limitation or problem for us to work with people in the world.
And you talk a lot with the companies in the Silicon Valley, or maybe how about startups? Can they talk with you and say, hey, we want to do something special, and you might be interested to do some interesting prototypes with them, or?
Actually, we talk to a lot of startups, but the case is we only can provide the standard demo kit at this moment, because if they want to kick off a new project, maybe they don't have enough funding to kick off the new project, because they need to pay a lot of money to not only to PlayNitride but also to TFT makers. The TFT makers will charge a lot for the backplane design. So for startup, it will be difficult to kick off a new project, but maybe they can use our current products to build their prototype. That's no problem.
All right. Do you think there's a future where all the smartphones are going to use MicroLED? Because smartphones is billions of products. It's a lot of people using them.
The smartphone, we hope so, but the smartphone maybe it will be the most challenging, because smartphone, the display of smartphone, the cost is not the cost is low, and the quantity base is very big. So for MicroLED, because it's new technology, so currently relative higher cost, and also the volume is not that big. So we will need within the smartphone business, that will happen. It will happen, but not the first or the second one. Maybe it will happen later.
I love Pico projectors, right? And these little projectors. And my dream is to get a Pico projector with 4K that's really bright and so small. And hopefully, I don't know, hopefully the MicroLEDs can help in this area, I'm thinking, to make it happen.
Sure.
And I'm hoping 1 or 2 years. Can we see something like that in 1 or 2 years, or?
Well, I'm not sure.
Okay.
We are, because we all have something new, maybe I mean, like a full HD or higher, this better resolutions samples next year. But it depends. Usually, if you want to make the consumer product, there will be lots of the validation or evaluations, and make running the reliability. So the product life cycle, after kickoff, then you can see the real product in the market. Usually takes 1 year to at least 1 year, but usually will be longer, maybe 1.5 years. So even we can provide the display next year, but it still takes time to the market.
All right. So Norman is sending a message right there. Can these be made onto a flexible subsurface? You see that question?
We did not demonstrate here. Actually, last year we announced with AUO. They have a 9.4-inch flexible display. So the thing is the same as the rigid one. So right now the rigid one is TFT on glass. So the flexible one is TFT on usually TFT on polyimide. So that's just like flexible OLED. It's a very typical process for TFT makers right now. And we just mass transfer the MicroLED chips on this TFT polyimide, that we can very easy to make the flexible display.
Is it similar to that one you were showing in 2019?
Oh, actually not that flexible. What we showed that time, because there's a single PI without TFT. But for TFT, because there's some of their design requirement, and there's not more driver ICs, so it becomes like a more it's one-dimensional bending. It's easy, but if you want to make the 2-dimensional bending, then there will be some of the challenges, just like a flexible OLED.
All right, because I really think it's interesting to see those slidable phones, foldable phones. Right now they're a little bit expensive. Like some of the companies sell them for $2,000. But it'd be interesting to see if MicroLED becomes a challenger in that market.
Oh, we hope so. Yeah, but it really depends on the. We can make it. There's no problem, but because as I mentioned, there's lots of tests and need to be done to make sure you won't get any phone and complain it. So it really takes some time to run all of these tests.
All right. So thanks a lot for showing your Display Week 2021 booth exhibition here on my YouTube channel to show some of your latest tech. And looking forward to see some more. I will link to your videos. Maybe we can link them later if people want to see them in higher quality and to see more demos. It'd be interesting to see what happens. And I hope we see millions of devices shipped, and it will all come from your technology, and that will be cool. That will be awesome. It's going to be a historic video. People can watch my videos to see PlayNitride 2018, 19, and 2021, and 2022. We'll see what happens.
Yes, we are looking forward to it too.
All right, and thank you very much, and thank you everybody. Thanks everybody for watching.
Thank you, everyone.